Hello, this is Ms. DB, and in this video I'm going to review how to do the last part of the 7.2 worksheet on similarity or ratios and similar figures. And in a previous video we went over how to do the first part of the worksheet. So now we're going to look at how do you use similar polygons to solve problems. So the first thing is, if there isn't a picture, draw a picture. Then you need to figure out how do the two figures go together. So if it's a rectangle, look for the short side and the short side. Those two are in the same, those are the corresponding sides. And the long side and the long side will be corresponding sides. So you're going to write a proportion. Don't just randomly pick sides and plug them in. Now some of these don't have pictures, a lot of them don't. So you need to start by drawing a picture, a quick sketch. So in Word you can go to Insert, Shapes, and grab a rectangle, because this one is about a rectangle, and there's two of them and they're different sizes, so I'll draw two similar rectangles, more or less. It doesn't have to be super exact, but make one bigger than the other one, and then I'm going to label these so that I know what I'm talking about for what side goes with what side. And when you draw them, you might as well draw them in the same so that the long side is in the same place on both of them. So I have a rectangle that is 3.2 centimeters wide and 8 centimeters long, and a similar rectangle is 5 centimeters long. Oh, so I should have made this one smaller. See, this is the long. Let me fix this should have been a littler rectangle. I guess I have to grab some other tool here. There we go. Let's make that one be 5. Okay. Now, I am looking for the width of the second rectangle, which is the shorter side. I could have labeled this 5 up here too if you prefer it that way. So when you write your proportion, make sure that you're plugging in short side over long side of one figure is equal to the short side over the long side of your other one. That's one way to do it. Another way to write the proportion would be short side over short side is equal to long side over long side. Both of these proportions will give you the correct answer if you plug them in correctly. So if I'm going to use this method, short side over long side, I would have, I'll write that one up here, 3.2 over 8 is equal to, now the short side on this one is labeled x, I don't know that, that's the unknown, over 5. And then you would solve it by cross products are equal, so 3.2 times 5 is equal to 8x. Let's look at if I had set it up the other way. If I had done short side over short side, I'd have 3.2 over x is equal to 8 over 5. And then I'm going to solve by cross products are equal, so I would have 5 times 3.2 is equal to 8x. Now look at these two equations that you have to find your variable. In one it's 3.2 times 5 equals 8x, in the other one it's 5 times 3.2 is equal to 8x. These are equivalent expressions, equivalent equations. They're both equal to 8x. On the other side you both have 5 times 3.2. So you'll get the same answer whether you set it up using this kind of proportion or using this kind of proportion. Now the second, so you'll have to finish this problem. I didn't finish solve the proportion. The second one I want to look at, because this one's a little bit different. So in this one we do have two rectangles again. You can use the same rectangles you used before. And I'm going to label these with their letters. So this is, let's see, CD, E, F, and it's similar to rectangle G, H, J, K. So because C is first and G is first, they have to be in corresponding locations. And then D goes to H, and E goes to J, and F goes to K. All right, let's see what else we know. This is an F. I know that the similarity ratio of CDEF to GHJK is 1 to 16. That means that, let's say, CD over GH is equal to 1/16. That's the similarity ratio. If DE is 20, what is HJ? So I already know that side CD over side GH is equal to 1/16. And we also know that DE over HJ will be equal to that. So method 1 is to write a proportion using the 1/16 as one of your ratios. So we're going to do the proportion that DE over HJ, which is 20 over, let's call this X, is equal to 1/16, because that side DE over HJ is equal to the similarity ratio of 1/16. So that's one method to solve. The other method is to do more of an algebra solution. Since we know the similarity ratio is 1/16, the larger rectangle is 16 times bigger than the small. Each side length will be 16 times bigger. So we can use that. So I could say that 20 times 16 is going to equal the missing side length. And you'll see if you do both of these, either way, you'll get the same answer. So there's two ways to do it if they give you the similarity ratio. And then you'll solve some more problems like that, 8, 9, and 10. And then in 11 and 12, you're going to be using some real-world problems. This one is about a town in Kansas. This one, some of you may know this one. It's in Vernig. I think there's an R in there. Up by Detroit Lakes, they have this statue park of ordinary things that are made large. And I actually measured this when I was up there. So you can figure this out and see how to do this one. This one's similar to the last one, where they give you the similarity ratio rather than the actual length of something. If you have any questions, please ask for help. I'm in my office hours or in the ASC room lots of times during the week and available by email anytime. Thanks a lot and have a wonderful day.